Often when we're programming, we might find ourselves in scenarios where we want to be able to save the data that we've gotten from our program and then be able to either look at it later or be able to re-import it into our program or be able to send it to somebody else. And we might be able to do the same thing with other files, right? So if somebody else's program outputs something, or we know that there's something else that we want to read, like let's just say information on a person or an image file or something like that, then we need to be able to do that, right? So here, let's take a look at some file input and output and try to be able to do that. Now, I've already created a file here in advance called inputexample.txt, and it's just going to contain a name, an age, and a address. And what we're going to do here as a starting point is just try to get this out of a file and into our program, and then we'll do an example where we simply write this out to a file as well so that we can see that for an example. And then we'll go into a little bit of how to handle cases where there might be issues with the file and just general error checking. So here on the school server, I've created the same file. It's got the name, the age, and an address. And we're simply going to try to read these three things into three variables and then be able to use them in our program, basically just to print. We're not going to do anything too special with it here. And I do have another example that we'll get into in a bit. Okay, so now we're here in the programming side. Let's try to look through some of the stuff that I already have here. You'll notice at the top I have IOStream, which is what we're used to. And IOStream is input-output stream, right? So it contains cin and cout, which are where we've normally been writing to. We have an alternative to this. Instead of a normal IO stream, like cin or cout, we can do a file stream. So here I've included a library called fstream, which stands for file stream, and this is going to allow us to do basically the same sort of things that we've been doing with cout and cin, except with a file instead of a normal stream like the terminal, which is cin, and the terminal again for cout. Right, is we can read from the keyboard and output to the terminal, and those were cin and cout. We can now do exactly the same thing, but using files instead. I've also included the string library just for the sake of it. We may need it in the future here. Now, first things first, let's go over how to open a file. What I'm going to do for the sake of this program is I'm going to read that file name in from the user. So here, I'm going to do it as a command line argument. So remember, in order to do that, we need to have argc for the argument count and then the argument vector, which I'll do as a character **argv. And I am going to do some checks here. So first things first, we haven't gone over error checking yet. In this video, I hope to do that as much as possible. So far, we've been assuming that the user is going to always give us the correct stuff for our argc and argv and any sort of things that they give us in cin. And because, like I said earlier, that file streams work like cin, I think now is a good time to try and address how we handle things when they don't enter it correctly. So we'll work through that as we go here. Now let's say they're not doing things correctly in terms of starting the program, so what we want is for them to give us a file name to open. So this program is going to ask on the command line, can you give me the file name? And we're not going to prompt during the course of it, but when the program starts running, you need to provide the file name with it. So here, what I'm going to first do, now that we know how to use if, is we can check if the argument count does not equal 2. So here we want our usage. I'll comment at the top, usage of program. I'll just say it's ./a.out. Let's put space, ./a.out, and then the name of the file that we want to open. So we're going to get that in as a string. So here, if the argument count is not equal to 2, then that means it's either less than 2, which is 1, so it would just have this program name here, or that could also mean that they put some extra stuff here afterwards, right? So they put A, J, K, whatever, some numbers. They just put stuff that we don't want. And so if they give us an incorrect argument count, let's go ahead and tell them that's not valid. And we can do that by simply printing a message. So we'll say cout incorrect usage. Program is used like, and then I'm simply just going to put this up here. And now if they don't use the program correctly, it will exit. What we do need it for it to actually exit the program though is I need to return from main, and I'm going to return 1. Again, if you didn't watch one of the previous videos, 1 is the error code, or a error code. It's going to be the one that I am using. 0 is success, and 1 is an error for now. And so what this will do is whenever it encounters a return, it will return out of whatever function you're in. We haven't gone over functions yet, but main itself is a function, so what this line does is it just exits main, and it lets whatever is running main know that it exited with 1, which is the exit code for an error. Right, so that handles people not using it correctly. Now let's actually try to go and open the file. So first things first, I'm going to create a string, and I'm just going to do this for the sake of readability. I wouldn't normally do this, but I want to make this more clear. I'm going to do file name, and I'm going to grab it from argv1. So that would be the first argument that we call this with, right? When we run it, we're going to do ./a.out and then the file name, and the file name will be the first thing in the argument vector because the 0th thing is the program name. And what we want to do is we want to open a file. So there are true data types that we're going to go over here. Remember that we've been declaring these with just, int and then a variable name, or character and then a variable name, or float with a variable name. We do the same thing with custom data types as well. So there's a custom data type for files, and it's called a fstream. So it stands for file stream, and there's 2 types of file streams. So first off, there's the input file stream, which is for reading files, and then there is an output file stream, which is for writing to files. Here we want to read in the file that I have on the server. So what we're going to use is an if stream. So I'm going to take an input file stream, and I'm just going to call it infile. Now there are 2 ways to open a file, at least 2 ways that I know of, and I'm going to primarily use the second one, but I just want to address the first one in case you see it if you are looking for things. And one way we could do it is we can simply put the parentheses after the name of the variable that we're creating the file stream for. So here I have if stream infile is going to be the name of my variable, and then I would simply give it the file name. And what this will do is it will input the file and open it that way. So here, if I ran my program with the example input.txt, it would just open a file called inputfile.txt and set it to be in file. What I'm going to do instead, so this is totally a valid way to do it, is I'm going to instead do it with the open function because I think that looks a little bit nicer. So here I will do infile.open, and I will choose to open it. There we go. So that just opens the file with the given file name, and now we can actually use it. One other thing I think I would like to mention, because I get a lot of questions about it from people who are just starting out with computers, is what does the file extension mean? So here, for an example, the way that we're going to run this in a second is we're going to do ./a.out, right, to run our program, and then I have a file name on the server for the file that we were using called example input.txt. Right, so whenever I run this in a second here, it's going to be example input.txt, and that will end up being the file name when we run it. So the question I get a lot is, does this file extension matter? Do I have to put .txt? I see a lot of students worrying when files don't have the .txt, they think they can't read it, and that's really not the case. So the file extension, whenever you're doing a file, doesn't actually affect you at all. It's simply there as a way for the operating system to associate the file with a kind of program. So a .txt file might get associated with Notepad on your computer or whatever text editor there is on Mac, and it will simply open it for you to be able to read it. Whereas if you opened up something like a JPEG or a PNG, it would open with an image viewer. But if we think about it, a computer is really just operating in binary. So if I save something as a text file or I save something as a JPEG, the only difference there is just telling it what the contents of the file are. It's still binary, so anything really should have the ability to be able to read it. So me simply putting a .txt at the end of this file is kind of inconsequential. Even though the file we saw earlier has a name, a number, and a address, there is totally nothing stopping me from naming this example.png, which is an image format, and being able to read it as if there was no problem. A PNG simply tells it, oh, maybe you should open this with an image viewer, but it is still just a file. That being said, you should try to put extensions in your file names if you want to associate it with something. So here, .txt is maybe nice if you want to open it in a text editor, but there's definitely nothing stopping you from not putting a file extension or putting something kind of nonsensical or something that you just made up. You can put any word after the dot and it will be the file extension. Now that that's out of the way, let's go ahead and actually try to read this. We opened the file earlier, which means that we now have access to read it. So the first thing you have to do with any kind of file is be able to open it. So the computer is storing it, we need to open it in order to see what is the contents of the file. After that, we will begin our reading. Now, because it is a stream, which is the same thing that the cin and cout have been so far, we can actually use it in pretty much the same way. So I can use the normal operator like this, the insertion operator, to be able to read things. So here, just for an example, I'm going to simply take a string and I'm going to call it example string, and then I am going to read it here. And let's just see how this works. So I will cout example string, and we will see exactly what it is that we read. So here we'll say I read, and then a space, and then we'll put that there. And I will delete this later, it won't be in the example, but let's at least see what it does. I'm going to transfer this over to the school server, and then we'll run it there. Okay, so we're over on the school server now. I'm going to go ahead and compile and run it over here. You'll see that I have a file called fileexample.cpp, and that's the one I'm going to run here. So let's go ahead and compile it first. So g++ fileexample.cpp, and then it will give me my executable because it compiled, and we'll simply type /a.out, and then the name of the file. So remember we said that we're using a command line argument here, so it was called example input.txt. And you'll see it says I read John with no space because I accidentally forgot to put a space here, but it only read John. And if we look back at what we know the file contains, it contains a name and then an age and then an address. And so you'll see that it only read the first name of this person but not their last name. And the reason it does that is because when you read a string with the insertion operator, which is what we did here, right? We read this with the insertion operator, the two right arrows, is it will only read up to a space. So here, it will read up to only the word John. And so let's take a moment to talk about the file pointer that will go through your file as you're reading it. Whenever you open a file, or wherever you do things in the terminal, so this has been happening while you've been doing cin as well, it just works a little bit different because you have the enter. It will basically start with some kind of arrow, which we will call a pointer here, and it starts at the beginning of the file. Whenever you do any sort of read operation, it will look at the things in front of it and try to read it in the way that it knows how. So here we asked it to read a string. We wrote the code in file, which represents the variable for this file in our code, and we simply put a string here. So I don't think I called it str, but let's just say there's some string variable. And so what it will do is it will look at what is ahead of this green arrow, and here it will see the word John. And it will, when you read a string, it will go and see what there is until it hits either a space or an end of line. So here there is a space after John, which is why it only reads John. So the arrow, which was right here before, is going to read until it hits a space, and then it's going to end up over here, and now this is red. And so it always goes left to right, and even though we don't really think of it, there is a line feed in here, which is still part of the left to right part. This is actually just to the right of this, but for the sake of convenience, I've been writing it on a new line. If I was to read another string after this, it would read computer, and then 27, and then 1101, and then the binary, and then the highway part. Right, so it has ways of handling strings, and it also has ways of reading other data types too. So if I wanted to read a number, I can simply do it the same way with the right arrows. If the file pointer was just, let's say here, for an example, if it was in front of the 27, and I had random garbage after this, ABC, then one thing to note about reading with something like input, or integers, if I read in file into an integer for another line, then it will only go until it finds something that wouldn't make sense in an integer. So if I did this line with this pointer right here in front of the 27, it would actually only read up to there. So it would update. It would see the 2 and then it would see the 7. Those make sense as far as a string goes for an integer representation. But the letter A, B, and C don't make sense in an integer, right? And so when you read something that is a predefined data type, like an integer or a float, it will read until it encounters something that no longer makes sense. And that's different than a string because that will always go up to a space or a line feed, whereas this goes up to things that are parsable. So here for an integer, it will go until it encounters a letter or something like an exclamation point or a comma or even a decimal point, because you can't have a decimal point in an integer. And if you had a float, it would read anything with a number and a decimal. Anyways, back onto the note of this file. I'm going to erase all of this extra stuff that I added to the file that's not actually there. This is where we were with actually reading our string. And we said that this was kind of an issue if we just read strings, and they are going to end whenever we have a space. So we're going to need a different way to be able to read this than the way that we've been reading things with cin, with that double arrow insertion operator. We're going to need to get a way that reads until it hits the end of a line instead of until it hits a space. And there is a way to do that in C++, and it's called getline. So here in my code, I am going to use that instead. I just want to do this for an example. We're going to throw this out. If I want to read until the end of a line instead of reading a string normally, I simply use getline, and it's a function, so you give the name of the function here, which is getline, and then we will need to specify two things at bare minimum. We're going to need to specify where it is that it's reading from, so we want it to read the next line from the file, and then we need a place to store it. So here I want to store it in this thing called example string. Let's actually rename this so we have some better variables. We had a name and an address were the two strings from this file, and then we had an int age, right? So I'm going to create these variables in advance. So if I did getline and then name, what this will do is it will get a line from the in file and store it into name. So gets the first line of in file and stores in name is exactly what this does. Right, so if we go back over to the way our file looks over here, what this will mean, hopefully let me go back pretty good. If we open the file, it starts at the beginning, right? We have a file pointer here at the start of the file. If I do getline instead of what I have here, getline will go until it ends the line. So getline in file and then a string to store it in is going to simply take the pointer, which is right here at the start, and it's going to read until it hits the end of the line. So it's going to end up here-ish. Or you could say at the next line too, if that makes more sense to you. But it's going to read until the end of the line. So all of this is going to get read. And now if I ask it to read something else, let's just say the integer here. So if I said in file, and then now I try to use the operator, which is the insertion operator, and I try to read it into some kind of integer, which we're going to do here with the age, then it's going to be able to do it successfully because the next thing in the stream is an integer. So if we look at this, it got to the end of this line, the next thing it's going to see is this next line, right, which has a 27 on it. So if I do that, it is simply going to read the first thing that is an integer there, assuming that it is an integer. If it can't find one, it's going to throw an error, and we'll get into error checking as we go to the end of this. So let's go ahead and try to finish our reading here. If I do this, we should want to read the age next. So just as a refresher, we know that the file has a name, an age, and an address. So we maybe have information on people that we were storing and we wanted to get it now into our program. We read the name already. We're going to read the age via infile. And for this one, I can just use the insertion operator because it can just be read normally. I don't have to go to the end of the line. And in fact, I don't want to because that would return a string and I want an integer. So here I'm going to do age. And then the last thing I'm going to do is getline again. And I'm going to get the address. And now because we know some information about this file, we're done. If we had a file where we didn't necessarily know all the information in advance and like exactly the formatting, we might have to do something different, and that's what our second example is going to be here in a moment. One last thing to note about getline before we move on is that getline doesn't necessarily always have to work with just a line feed. It does that by default, but if you wanted to make it work with something else, you totally have the option. So if I wanted to have it work up to semicolons and then stop reading, I could simply give it an optional third argument here with a semicolon, and it would read until it encounters a semicolon. So if I had a semicolon, let's just say in our test file here, if I had a semicolon after, let's just say John C here, then it would read up until John C and then it would stop, and then the next thing it would read would be OM puter after that. So you can have it read up to characters that aren't necessarily line feeds or line breaks. You can have it read up to other characters as well. So I can have it read up to the letter C or the letter O or something like that if I decided that that's the way I wanted to do. And you'll notice that that's kind of a common file format for things like CSVs, right? If you've worked with Microsoft Excel before, that's a comma-separated values sheet, and it just separates all the values with commas, so it knows to read up to commas. Then we would do getline with a comma. Anyways, let's go ahead and copy this over to the server again, and then we'll go ahead and run it. Okay, we're back on the server. Let's go ahead and recompile G++. Actually, one thing while we're here, when we run it, if we don't specify a file name, you'll notice I had argv1. You'll see that it catches the incorrect usage. Let's just test that. We'll see, and it checks that thing that I had. If you don't do this error checking, you might accidentally end up using a file name that doesn't make sense, and you might get something like a core dump or a seg fault, which basically just means that it has some issues with memory because it couldn't open the file. So we might have to address if the file doesn't exist here as well. Anyways, actually, I guess I could do that here too. So let's just say I created or tried to open a file called like test.txt. I don't think I have one called that. You'll see that the program just does nothing. And that's actually a pretty good result. A lot of the times it will just crash and give you a message about it, but I suppose it didn't do that here. We will try to do the function here in a little bit just to test if a file exists before we open it. Anyways, I don't think I am giving any output. Is that my issue? That would be my issue, so I'm not actually printing anything. Let's go ahead and add that and I'll recompile. Okay, I've gone ahead and changed it so that it will just print all our variables. Let's go back over to the server and I will recompile once more, and then we will run it. And so you'll see it says John Computer 27, and then the address seems to be getting hung up for some reason. So we seem to be getting some kind of issue with it reading the last line, the address, and I have a wager as to how we can fix it, and then we'll just explain what the issue is. So what I think we should do is we need to do an extra get line here. For the sake of readability, I'm going to do a variable called throw away. Sometimes when you read things, it might not actually go to the end of the line. So what I think is happening with the age here, if we look at this file that we had previously, is I think it's ending up here and it's actually reading the 27 and stopping before the line feed, and so when I go to read the next part, it's just getting the extra blank space that's over here instead of the address that we wanted to get. So just if you think that's happening and it's not getting it, we can just try to read some extra stuff and then throw that away. So here I'm going to read from infile and I'm going to put it in the variable throw away, and we'll see if this fixes it. So I'll recompile. I will run it, and we see that it does not work. So I think that was the issue. There's another way around this. We could always just get line consistently if we want to, but just consider if you do that with the file we have here, if you get line always works on strings, so you would need to convert 27 from a string to an integer using something like a to I if you're to do it that way. So we just have a kind of a quick fix here, maybe not the best way to do it, but sometimes when you're reading files and they're formatted a little bit incorrect or they're janky with the formatting, it's good to know that you can read into something that has garbage. So here I just created a garbage variable, just read it into a garbage variable and just throw it out for later. So it's probably a good thing I had an error here, because this is something that I feel like you may encounter a lot if you input files. It's totally okay to just throw stuff away if you don't think you need it. Anyways, I think that about does it for our simple example here where we read a file from the input. Now, I think we'll split this up into 2 videos because it is taking a little while for this one. It's quite long already. So I'm going to do another video on reading files and handling errors with files where we don't know the structure of it. So this one we knew was formatted with a name, an age, and an address. I'll do another video where we talk about how we would do it if we didn't know the structure completely in advance. But before we do that, let's do one last thing, which is let's write this output with the name, the address, and the age to a file instead of writing it to the terminal. So far we've had it print just here in the terminal, right? Let's try to write it to a file. And so the way we can do that is just by creating another kind of stream. So if stream is an input file stream, it allows us to read in a file, and an output file stream will allow us to write out to one. So here I'm going to create an output file stream and I'm going to call it an out file. Before we do that, let me simply throw in this line here. Let's close the file. If you keep a file open, it will be left open as far as the system goes, and so you won't be able to open it anywhere else. If you decide not to close it, the program will close it when the program ends, so that is something to be aware of. But it's good practice to close your files so that you don't just leave it open, especially if your program takes a long time to run. You might just open it and forget to close it, and then you now can't look at your files because the operating system won't let you because it's being used by your program. Anyways, I'm going to create an out file here, and we're going to write the output of this to a new file. Now, the nice thing about writing an output stream as opposed to an input stream, so an input stream is subject to not being able to find the file if you provide a name of a file that doesn't exist. If we do the same thing with an output file, what it will do is it will create that file if it doesn't exist. So I'm going to create one called example. Let's just say we call it example output. And I won't put a file extension, but you could totally put .txt or whatever you want. Just for the sake of an example, let's not use any file output, any file extension. Let's go ahead and just write it like this. Now the way I write out to a file, we could do it with a function, so we could do outfile.write, I think works. Alternatively, because it's a file stream, and specifically an output stream, we can use it exactly like cout. So cout is an output stream that we've been using so far. We haven't really been calling it as such, but it is almost exactly like a file. And so I can use files in a very similar manner to cout. Here I'm just going to replace all of these instances with cout, with outfile of cout, and we should see that when I run this program now, it will output to a file called example output. So let's compile it one more time. We will run it, and you'll see that now I get nothing in the terminal from running it. And the reason that is because if I was to ls now, you'll see I have a file called example output. And it didn't exist before, but if I view the contents of that file using cat example output, you'll see that it is in fact what we expected to be outputted to the terminal like we had earlier. So earlier it was outputted to the terminal here, so we can write to a file. And so now we have the ability to both read in from a file and write out to one, which means that we can save our work for later, or input other people's work, or work on things that we think might have to do with our program. Anyways, in the next video, it will just be an extension of this one. We will simply take a look at reading things where we don't know the format of the file and then handling errors.